This is Mike Berg, and I'd like to say hello to you all from my home office to yours, and welcome to our short form webinar here, which is on the industrial network infrastructure, your future business foundation. So, how important is an industrial network to the business it supports? It's manyfold across the organization. We tend to think of networks of how they affect us in the office workspace, where a slowdown or a brief outage might make for talk around the water cooler. But in contrast, with industrial networks, they control and communicate the status of our profit-making assets. And therefore, it has impacts on our workforce productivity significantly. And the outages and the slowdowns are extremely visible, and they can be readily monetized. And this can often have some career limiting consequences if you're the designer involved. So a network outage can hamper, even idle, a very productive workforce during an unplanned outage. And this causes the business to not only lose production output, but we can incur salary costs that don't result in profitable production. So while network health isn't always the sole focus of the business, if it was not causing problems, the business could focus on more important tasks. So we're going to touch on now why it's important to have both a current plan and a future-looking network plan. So we're going to look at network cost distribution, and we're going to use this little triangle here and talk about how projects typically break down from the network perspective. So as we went out and studied project expenditures, we examined the relationships between the network elements and where the dollars are invested. So software is usually the biggest piece, and it's a sizable one of about 60% of the project budget, and it usually has a life cycle of 2 to 5 years. So software updates can drive the process improvements, and that enhances profits. So the network hardware, the switches and devices that we're implementing out on the plant floor, they come in second, and they have another big chunk of the budget at about 23%. And these have a shorter lifespan than what we're used to on the plant floor. So they usually have a lifespan of about 5 years. So typically our industrial gear would be used much longer, but if it's something that's got Intel inside, it changes out a lot faster, every 3 to 5 years. Technology upgrades happen quicker on the network side. About 10% of the budget is with operations. So this is the field technology, tablets and things like this that is being used on the plant floor to support operations. And they also have this 5-year maximum time frame with the technology as well. And then finally, we have the cabling and the infrastructure, or what we call the network physical infrastructure. It has the longest life cycle, which you're probably familiar with, 20 plus years, sometimes even longer than that. And it's about 7% of the project spend. So with cabling and infrastructure, it's often viewed as the relief valve used to control those initial investment costs. But in turn, it also determines how well new technology can be adopted over time. So it's kind of the platform that all these other things above here are relying on over time. So we may initially work well, but then over time, maybe we're not working as well from the infrastructure standpoint. And we can see from above that the switch hardware and the people technology will change out at least 4 times over the infrastructure lifespan. So we need to think about, as we're talking with the users of the system, how tech driven is the company that we're working with? Knowing that answer can help us make better design choices. And we also need to recognize that a large percentage of the network problems, 50% or greater, are happening down in that cabling and infrastructure layer. So we need to look at what's the cost of downtime, how much pain does it cause, and can we create a design that has greater reliability? So we're not saying to flip that triangle in terms of investment. We would love it if that happened, but it probably won't. But we can say that we can use this life cycle of components to plan more smartly. All right, so we also looked at best in class networks. And we thought to look at what are the types of things that the best-in-class manufacturers do in their networks when it comes to the physical layer. So what I'm showing you is from Aberdeen Research, and they conduct a study in this regard. And what they did was they asked a lot of manufacturers questions about what they do with regard to their industrial network. Some of those are physically related. Those are the ones we're going to talk about here. And then they also kind of segregated who answered based on their performance level. So they segregated out the best in class, which will be the light blue color, and then also everybody else. And I'll define what that best in class means here in a minute. So there's 4 key areas that they looked at that relate to the physical layer with differences. So reliability built into the network physical layer. Big difference here between the best in class and all the others, a 30% difference. So it really stands out. Reliability, redundancy built into that. And then data link reliability, also a big difference there between what the best in class manufacturers are doing and what everyone else is doing. We looked at network management, a little bit smaller impact there, but still some differences between the two. And then we also looked at the cable management strategies and how well those are aligning to the industrial network architecture. And there's a pretty significant difference there between the best in class and everybody else in this study. So when we look at the best in class, how they defined it or how they segregated it out is pretty effective numbers here. So 99.91% uptime, which is 8 hours aggregate downtime per year. It was 11% reduction on average in the total cost of ownership. It was a 90% OEE, and typically world class is considered 80%. So this is some pretty good OEE, and then a positive 25% operating contribution margin. So 25% more profit going to the bottom line with these companies. So this is significant, something that we should pay attention to when we're designing and trying to build that reliability into the system, and maybe even adopting some of those IT practices where it makes sense, because all these things can be contributors to success out on the plant floor. So where we're going to go next is talking about where do I start? So where we need to start is to really figure out what's out there, right? That's the natural course of where we're going to take things. And that starts with network assessment and documentation. So we saw in that previous slide that many are conducting network management, which is really good, or doing a little bit of monitoring. Part of the problem that we encounter though is how we're documenting that network. If we're documenting via prints, they're usually good on the first day, and then after that, everything changes, right? So it's a little facetious, but actually it's not all that far off. It's far easier to make a change in a pinch physically, but it's far harder to get it documented. And updating CAD for a minor change is not typically viewed as a high value activity. It tends to wait. Our experience using more network-based tools in monitoring network is that the typical plant floor scan turns up 20 undocumented devices operating on the network. The second thing to look at is really a mitigation plan for problems that may occur. This also relates back to that previous slide, right? The difference there between what the best in class was doing and what everybody else was doing in terms of reliability and redundancy planning comes into play here, right? If something goes wrong, what is our backup? How do we come back online as quickly as possible? Real-time information on the network is also very important here to avoid unforeseen effects that could happen in the network, things that we don't know are going to happen. Our next step is really looking at, are we engaging well with the organization? So the network maintenance and operations strategy. Are all the stakeholders involved in this strategy? Do they all play a part? And are we putting in some fence posts on where this network should be? What are we defining it well, and how it could operate well, and what are expectations around it? And then the final piece is kind of a forward or future-looking plan. Planning for when changes are going to be made. It's hard to do a rip and replace strategy here. there's always going to be a migration strategy that's taken with these types of networks. So it's going to be in a lot of constant flux. We need to know what the overall strategy is and what the plan is for implementing it. Sometimes these changes are driven also by the ability to support systems as well. As the workforce changes, older generations, as they are retiring, they take a lot of knowledge with them, right? And then newer generations, they come along, they learned on different technology, and they want different types of things, different types of technology to support operations. So all things that need to be considered in our planning. The next thing we look at is really the state of the network. What's happening out on the plant floors? And so this is kind of the most current data that we have in terms of industrial Ethernet. And so industrial networks continue to evolve over time. And so the industrial Ethernet portion is continuing to grow. So in 2019, it was at 59% of the marketplace here, with Ethernet IP, Profinet, EtherCAT being your leading protocols here. It grew about 7% since the last time we saw this chart. So it's definitely growing in the space. At the same time, we're seeing a little bit of a cooling effect happening on the field bus side. The projections are of a shrinking of field bus to happen over time, so about 5% reduction. So it's certainly an advantage here with Ethernet coming on board and being more of a part of the control systems, that it can become a dominant protocol, and that can help us to create this connected system across the industrial network and communicating back to the enterprise itself. Okay, so we mentioned some things about network management tools. We definitely recommend utilizing the network management tools. The functionality of the network management tools gives us the ability to document the current state of the network. They also enable us to monitor network readiness, and gauge network performance and find faults and misconfigurations in the system. And they do this all through a single pane of glass, or they are capable of doing that through a single pane of glass. What's also important here with these network management tools is that they're valuable all throughout the life cycle of the network, from doing those initial health checks on the network and documenting the network through an assessment, through the operation of the network and future planning of the network. So they can be valuable tools all throughout. As we're looking at that overall strategy plan that we may be developing with the customer, we also need to look at how are we going to match up the physical network and the logical network designs. So that's what we want to address here with this slide. And there's three key elements we're going to call out here. So the reference architectures, like the one I'm showing you here, which is a basic one, they're heavily driven by the customer controls vendor choices and you as a designer, your preferences as well. But I also want to show you how the physical network can align really well to these logical models. So all the major control vendors, they have some type of reference architecture. Many are based from this basic Purdue model that we're showing you here, that are the colors in the background here. And they represent the logical reference architecture in a basic form across the plant floor. So there's also the physical network and how we're laying out the cabling and connectivity and connecting the switches that are being distributed out on the plant floor. The physical network is built aligned to the Telecommunications Industry Association TIA 1005-A. This is the premises standard for industrial. In this diagram, we've overlaid the Purdue model to the TIA 1005-A's distributor model here. This shows you how well these two systems align with one another, and that's by design. And then the third element here is being able to build to these systems. So we need to be able to build aligned to the architecture, right? We saw that in that graph, how that helps us be more effective, be more best in class. So utilizing systems that can be built with TIA 1005A in mind can help ensure that there's validation at each of these subsystem levels, level 3, level 2, level 1, level 0, cabling subsystem 3, cabling subsystem 2, cabling subsystem 1 in TIA. We really count on the expertise of our design and deployment partners so that we can adopt a format that provides reliability in the OT environment, addressing the environmental conditions, but also adopts the best practice of IT systems. So these systems are testable. They're also more reliable, a little bit more redundant as well. So from the logical and physical side, Panduit provides some education in this area, but there's also other areas that you can look at. If you're newer to this industry or you just need to brush up on networking, continuing education is always a good career booster. So think of it as being better informed and better ready as network requirements change or evolve within your organization or with your customer needs. Some of the common paths that fit really well with what we're talking about here today, the CCENT, which is the entry-level entry network tech, the CCNA, industrial CCNA, and the IMINs are all really aligned really well. And then the Cisco certified internetwork expert. So all things to consider. All right, so we talked about being forward-looking as well. So here's some of the future planning considerations, things to monitor with industrial Ethernet. So these are some of the technologies that Panduit monitors with regard to Ethernet, but the industry also as a whole is engaged from the control side, IT side as well. So power over Ethernet, we're talking about current technologies, things that are used in a lot of the buildings. You're probably seeing it used for security cameras, monitoring cameras today in the building space, but it also at some point here may have more of an impact in the controls design or even in more closer to the machine level as well. So this is something to monitor. They possibly could replace some of the DC devices that are out there today. As things evolve, this single pair Ethernet that's on the right, also power over Ethernet is capable on this single pair Ethernet, and we'll get to that in a moment. So time sensitive networking. We talked about how Ethernet is expanding across the plant floor. Time-sensitive networking is a very important thing to enable Ethernet to be delivered in the more time-critical applications where synchronization is involved, where we can have a more resilient network, more deterministic network. So this is present in a lot of different spaces. So industrial control, automotive, and things like audio, video over Ethernet as well. So 3 different areas driving that technology. Software-defined networking. This is kind of as we build up the ability with the infrastructure for it to be consistent, resilient, reliable, capabilities with software-defined networking with a predictable infrastructure, much more capable. Then the final one here, single pair Ethernet. This is something you may have heard something about. It's very prevalent in the automotive space, the building automation space, and fire alarm safety security, and also with industrial automation. The connectors are going to be a little bit different, a little more hardened on the industrial side. The driver here is really bringing the node cost down for the edge devices and being able to connect those edge devices so that we have visibility on the network to every device that's out there. What this system will also do, it's not going to have the same bandwidth as a Cat 6A or Cat 5E at this length, but it allows connectivity for that edge device up to 1,000 meters. So that's a really big benefit on the industrial side. So this technology is just starting to emerge. Connectors are, being designed, developed, standardized. Devices are soon to come online as well in this regard, but it's kind of an emerging technology, something that you should be monitoring as it happens. All right, so I talked about a lot of different things here in the last few slides. What I wanted to point out here as I move towards closing is that all of our companies here, we're playing maybe different roles, but we're in each area, we're critical in delivering these projects, right? We might be involved in that M&O strategy and in talking to that end customer day in and day out and really understanding who they are as a company. We might be really good at delivering structured cabling, right? And being able to test and validate systems. Or we might be more so at that controls level and designing systems and the industrial automation piece and at the machinery level. But all of those things are needed together to deliver this type of solution. And really the value that we're providing together is that any of us can make a promise to our customer base, and we know and we can rely on how the partners are going to deliver. So in closing, I want to say that Panduit's engaged with leading companies in controls design, structured cabling design and deployment, and leading distributor partners that provide key services, consultation, and project management. It's a common vision amongst these leading companies that makes possible the complex planning required, and the coordination between partners is a key factor that enables the greater reliability in network designs and deployments. If you liked what I presented here today, there's some things that really support this material. So I just kind of briefly went through this, but there is actually a white paper that talks in greater detail on all these topics. That's that middle one that says industrial network infrastructure. We'll provide this to you. And there's also case studies and even detailed what we call popular configuration drawings available that you can use in these discussions as well. So with that, I am going to turn things back over to Jane.
Thanks, Mike. We will use this time to answer questions, so please feel free to put your questions in the chat window in the GoToWebinar app. Mike, I did have a couple questions come in while you were talking. The first one is, I noticed on the graph where you showed the best-in-class percentages that network management did not have as large a difference. Can you comment why that might be the case?
Sure, and let me see if I can go back to that slide. I think I made it there. Okay, so what we're talking about is this third item, and there is a smaller difference between the best in class and everybody else in the study that was conducted. So I'm kind of speculating here on my own, but a couple of reasons why I think that might be the case is that, you know, network management it's a documentation, it's a way to document the network, but it's also a necessary item for security and patch updates and things along these lines, right? So there's multiple drivers for why these things are needed. And it's also tends to be like a lower cost investment. It's more of a software investment. And it's a way that people can better understand what's happening on their network. So this is actually a good sign that more companies are taking advantage and taking a good step towards improving the network.
Okay. Looks like we have one more here, Mike. Looking at where to start in the reference architecture, what are the triggers to start a project or this development work?
Okay, let me see if I can go to this one here. Okay, so this is close to where that question would be asked. And what I can say is that there's many different drivers that can relate to where the physical network is going to come up. So there's going to be new production lines. There's going to be, you know, major pieces of control equipment that might, you know, go obsolete at some point, or they need a migration plan. When those things happen, they're often at some point linked to a network upgrade. So when I'm going to the new piece of technology, I find out suddenly now I need a more updated network in order to be able to use it effectively. So that on some level that initiates the physical network, but the real reasons where the deep dive happens and we start looking at the M&O strategy really relates to a couple areas in my experience. The first one is the loss of production with downtime and maybe even like continuing support issues with the network where it can be monetized. And then the second one is really around major corporate initiatives, things that might be data driven, monitoring processes in real time where we need that connectivity all the way to the edge, or really technology driven as well. It could be people technology, but it could also be like an increase in the amount of automation, which is possible. We're going to see a lot more of that with what's going on in the world these days. We're seeing this increase in automation in markets like e-commerce, where there's a lot more robotics, collaborative robots working with people, AGVs out on the plant floor. These types of initiatives prompt a need to go through and review that network strategy.
Okay. It looks like I don't have any more questions at this point. We'll give it another moment for any other questions to come in. Please make sure to just type that question in the chat box. Okay, Mike, it looks like I don't see anything coming in here. We want to thank you for your time today, and we will go ahead and conclude the webinar. Have a great day.